In this episode of Finnoldrick Washington, we are going to do some bits and pieces for this crafting die press. Yeah, let's see how it goes. It's really small pieces, and hopefully this video doesn't become an hour-long episode. Well, let's start with something. Okay. This is the material for the first item that we are going to make. It is some shafting, and I have no idea what the material is, besides that it is some sort of an iron alloy. It is not soft, but it's not extremely hard either. I have cut off a suitable piece from it for the first item using my angle grinder. This is the angle grinder that I used. It is at least 20 years old, Black & Decker. It is amazing how these older tools survive the test of time. The cutting disc is a 3M Cubitron. These discs cut extremely well and do not heat the workpiece while cutting. They also seem to last a lot longer than the alternatives. They are not exactly cheap, but they are worth every cent I have spent on them. First, I face the other end properly in order to be able to measure the workpiece somewhat accurately. The material seems to cut without drama. Then I turn the workpiece around and keep on facing it until the correct dimension is reached. Next, I turn a 45-degree chamfer at the end of the workpiece. This is done by having the compound in a 45-degree angle and then feeding by it. The chamfer height should be at least 10 millimeters. Now I am making a 13mm hole through the workpiece. I start with a 12.5mm twist drill. Twist drills do not make straight concentric holes. Boring the hole will make it a concentric and straight. The diameter is irrelevant here, as long as I stay well under 13 millimeters. Now I am reaming the hole to its final dimension using a 13 mm H7 reamer. The boring made sure that the reamer goes straight, as reamers will follow an existing hole. If a hole is not straight, a reamer cannot rescue. That pinion will be glued into the hole. Now I turn a 25-degree chamfer to the other end of the workpiece. The compound is in a 25-degree angle and I feed with it. I have already glued the pinion to the workpiece and now I am drilling a 10 mm hole perpendicularly through it. First I use a 10 mm carbide end mill to make a 9.9 mm drill a place to start from. This is now the 9.9 mm twist drill, which I am going to push perpendicularly through the workpiece. Now I am pushing a 10 mm H7 reamer through that 9.9 mm hole. After that, the hole should be a few hundredths of a millimeter over 10 millimeters. Now I am making two steel pins to hold two balls used as handles to turn the rollers. There is a M10 thread at the other end of each pin. I simply glue the ball pins to their places. The 8mm twist drill is used to keep the pins from blocking the 8mm bearing hole. Now I just wait for the glue to cure. After it has cured, I run a reamer through the 8mm bearing hole to remove any burr or obstacles therein. Now I can put it together and then test it to see whether it does what it is supposed to do. täytyy kameralla näyttää tätä. This is a die, which is used to cut off shapes from paper or carton. The paper is squeezed in between the die and some support material. In this case, the support material is polycarbonate. The upper roller needs to be driven to avoid the die from slipping while pressing. The cap adjustment needs a locking mechanism because it has a tendency to open while pressing. That works quite well actually. It's not frictionless and the height adjustment works really well. It's as I thought that it might be, so that it's not like slippery, so that it slips to different positions. It has some resistance to it, so that it you can put it to one place and it stays in that place. Okay, we still have some things to do with that one before I can give it to the real work. We need a wooden pedestal for it, where it stands, so that it's above, so that you can crank it. And then we need, I'm not sure whether this is needed, the upper roller should also be driven, maybe. Well, the original, which went kaput, that thing did have both rings driven to both rollers. This one doesn't at the moment, but I'm prepared to make that there is a gap for gear on the other end, so I can put it there. The challenge with that one is that the distance of the gears is changing, so there needs to be some sort of flexible system which drives that gear. Okay, well, yeah. In the next episode of Innotric Machining then, it will be the break. As you probably noticed, the plans change every now and then. Well, they do. And now, I will, it's a break for, well, let's see. It will be in the next episode of Innotric Machining. So, Till then, bye!